Hello everyone, today we are going to talk about pulse modulation. So this is our presenter. There are going to be four types of pulse modulation: PAM, PWM, PPM, and lastly PCM. What is pulse amplitude modulation? Pulse amplitude modulation is a technique where the amplitude of each pulse matches the instantaneous amplitude of the modulating signal, while the width and the position of the pulses remain constant. Why is PAM important? It forms the foundation for the digital techniques like pulse code modulation and bridges the gap between analog and digital communication. Application of PAM include internet communication where it is used in high-speed network like gigabit internet, and also the audio signal processing as the basis for compact disc, and lastly the television signal transmission where it was vital for analog TVs. There are two types of PAM: singular polarity, where pulses are entirely positive, and double polarity, where pulses can be positive and negative for better signal representation. Finally, there are two sampling methods: natural sampling, where the pulses follow the shape of the original signal, and flat top sampling, where the amplitude remains constant during each interval. For the signal representation in PAM starts with a message signal, a continuous sine wave that contains the original information to be transmitted. Second, the sampling signal is a periodic on-off pulse train used to sample the message signal at regular intervals. To avoid aliasing, the sampling frequency must satisfy the Nyquist criterion. The frequency sampling must be more or equal to multiply frequency message, where frequency message is the maximum frequency of the message signal. In natural sampling, the pulse amplitude follows the shape of the original signal. This is achieved using a pulse train that operates a switch or chopper. Meanwhile, a flat top sampling uses a sample and hold circuit to maintain constant amplitude for each pulse during the sampling interval, simplifying further the digital processing. As you can see, the graph in here are made by using a Scilab. So for the advantage and disadvantage of PAM, the advantage of PAM is easy to design using basic circuit like sample and hold. Second one is support time division multiplexing. Lastly, the basic for technique like PCM and digital telephony. So the disadvantage of PAM are it requires a larger transmission bandwidth, it needed for various transmission power, its interference of noise is maximum. In conclusion, pulse amplitude modulation or PAM is simple yet powerful technique that bridges the gap between analog and digital communication. It works by varying the amplitude of pulses to represent the message signal and serve as the foundation for advanced technology like PCM and digital system. PAM is widely applied in internet communication, audio signal processing, and television system. It highlights how efficient signal processing enables reliable and high-speed data transmission in today's interconnected world. That's all from me. Thank you.
Assalamualaikum, and I will continue this presentation for the second part, which is PWM. So, the first part, what is PWM? PWM is a modulation technique where the width of pulses is varied in accordance with the information signal, while the amplitude and position remain constant. The purpose of PWM is to encode information in the signal by varying the pulse width, which correspond to the data value of the input signal. There are four key features of PWM, which is the amplitude of the pulses remain constant, the width of each pulse represents the encoded data, it is classified under analog pulse modulation technique, and the last one, it reduces the total amount of power delivered to a load. So, what is the advantages of PWM? There are four advantages of PWM, which is the first one, noise immunity. PWM signals are less susceptible to noise interference compared to other modulation techniques, such as PAM. The next one is power efficiency. PWM allows for efficient power delivery by reducing the total amount of power supplied to a load. This is particularly beneficial in applications like motor control and lighting, such as DC motor. The third one is simplicity. The implementation of PWM system is relatively straightforward, requiring less complex circuitry compared to some other modulation method. And the last one is multiplexing capability. PWM can effectively share the same transmission medium among multiple signals, facilitating time division multiplexing. So, what is the disadvantages of PWM? The first one is higher bandwidth requirement. PWM requires a larger transmission bandwidth than PAM due to need for rapid transition in pulse width. The second one is increased power transmission need. While efficient in power delivery, PWM may require higher transmission power compared to pulse position modulation PPM. And the last one, the complexity in signal reconstruction. The reconstruction process can be more complex, necessitating careful design to avoid distortion during signal recovery. So for the last part, for PWM, what is the application of PWM in real-time work? The first one is DC motor control. PWM can regulate the speed and torque in the electric motors. The second one is lighting control. By using PWM can adjust the brightness level in LED and incandescent lighting system. And the last one is the communication system. PWM can encode data for digital communication, ensuring efficient and reliable transmission. That's all from me, and I will continue this presentation for the next part by Ifat Farouk. Thank you.
Thanks for explaining the part of PWM. Hi, my name is Muhammad Ifat Farooq bin Imran, and today we are going to learn about PPM. So basically, PPM is a modulation technique where the positions of pulse is varied according to the amplitude of the modulating signal. So how the PPM benefits? So let's explore. It resistant to noise. So PPM has a better tolerance to noise. It requires a low power consumptions and it reduces the interference. How the PPM drawbacks? So it also presents some certain drawbacks. So it requires basically a synchronizations requirement. So it has a multiple sensitivity and a bandwidth requirement. So move on to the next slide, which is the signal representations. So in the time domain, PPM signal are represented as a series of pulses with constant amplitude and width but varying positions. So the waveform show pulses shift in time based on the modulating signal amplitude, which each shift corresponding to a specific value of the modulating signal. So here are some applications of pulse position modulations. So the first one will be the wireless communication system used in wireless system due to its noise, immunity, and bandwidth efficiency. The second one will be radio control system employed in model aircraft for its simplicity and lightweight receiver requirement. And the third one will be the RFID. So it used in contactless smart cards and RFID tags for efficient data transmissions. So here are the conclusion and mathematical expressions for PPM. So mathematically, the positions of each pulse can be represented as a functions of modulating signal amplitude. For example, if A is amplitude of modulating signal at a given of time, the positions of the pulse might be shifted by a time t equal to Ka, where K is a constant scaling factor. So this relationship highlight how the pulse positions encode the information from the modulating signal, as you can see from the signal representation earlier. So in a summary, PPM is a modulation technique that encodes informations by varying the positions of pulse, offering advantages in noise immunity and constant power output, but requiring synchronizations and a complex detection mechanism. So I hope you understand the concepts of PPM. So that's all for me. Thank you.
Thank you, Farouk. Next, I will explain about the pulse code modulation, PCM. So, this is the method used to digitally represent analog signals. It involves three main processes: sampling, quantization, and encoding. PCM converts the information contained in the instantaneous samples of an analog signal into the digital format represented by a series of binary numbers. So what is the basic principles of PCM? Firstly is sampling, the process of taking measurement of an analog signal at the regular interval. Second is quantization. Each sample is approximated to the nearest value within a finite set of levels, which introduce quantization error. And lastly is encoding. The quantized values are converted into binary form for the transmission. Next is what is the advantage and disadvantage of the PCM? So if we can see, the advantage of the PCM is robustness to the noise and interference. Second is the efficient digital transmission and processing. And lastly is the standardization for various types of signal. And what is the disadvantage of PCM? We can see that the disadvantage of PCM is the complexity in encoding or decoding circuitry. And last is the higher bandwidth required for the transmission. So if we think where the PCM have been applied. So in our life, we can see digital telephony system like WhatsApp, second like audio recording, CDs, and lastly like video compression. So next is the quantization process. So this is the process of converting an infinite number of possibilities to the finite number of discrete levels, rounding off the amplitude of sample. So it has two types, which is uniform quantization and non-uniform quantization. The uniform quantization is a level are evenly spaced, and the non-uniform is a level are unequally spaced, optimizing the SNR for the specific signals. And what we can conclude for PCM is understanding PCM is essential for modern digital communication system. It serves as the foundation for various applications that enhance audio and video quality while ensuring the efficient data transmission. Key benefits include robustness, flexibility, and the standardization despite the challenge of the complexity and bandwidth requirements. That's all for me. Thank you.